Hello everyone. So let's continue our discussion on vibrations. We are going through very preliminary things, definitions, some terms we are trying to introduce. Let me continue in that direction. So in my previous lecture, I mentioned about the components of a vibration system, or also called as elements of a vibration system. There are four components which I mentioned last time. So mass, say for a linear vibrations, mass, elasticity, that is stiffness and damping, and fourth one external excitation or excitation. These are the four components. Okay, now I would like to continue further and classify vibrations. Okay, types of vibrations, classify vibrations, that is the topic I intend to discuss. Because in your syllabus, though this term is not mentioned, but they start with something what is called as free vibrations. Okay, to tell you what is free vibrations, these are a kind of vibrations. Okay, how that classification comes, that I would like to intend. Okay, for any classification, basis is a must. So what is the basis of classification? For example, you all are 5th semester students. Okay, I want to classify 5th semester students. Okay, what is the basis? Okay, based on the qualifying degree or qualification while taking the engineering admission. Okay, so that can be either diploma or PUC. So probably accordingly then I can classify 5th semester students, diploma students and non-diploma students. This is one basis. Just like that, another basis. I am just quoting, I want to impress upon you what is the meaning of basis, and according to that how we can classify you. Okay, so based on the permanent address, okay, where do you stay, what is your permanent address? Probably I can classify you as local students and non-local students, outside students. Like that I can go on giving hundreds of bases for classifying. So similarly here also the vibrations, okay, we need to choose some basis, and then based on that we are going to classify. Okay, so I am going to choose. So the basis of classification is very important, and I am going to choose the first basis, say basis number 1. Okay, accordingly I am going to classify the vibrations. Okay, presence of external excitation. Presence of external excitation. Excitation is basically a force or torque which is responsible for vibration. Remember, every force shall not induce vibrations. For example, imagine that I have a mass. Okay, so I have a body, say of mass 5 kg, and say this is a road. I apply say 1 kN force, say like this. In that case, what happens? This 5 kg force body will continue probably depending upon the friction, and with certain acceleration will start moving in this direction. And if you allow it to move, then forever, then it will go on moving in this direction only. That means any force you apply, that doesn't mean that you have vibrations. You have a special kind of force, which force should allow the body to move in this direction and pull it back and again push it back, like that. If that kind of force you apply, then only you will have vibration. That kind of force which makes vibrations, that is what I call it as external excitation. Okay, during vibration, that force is there or it is not there. This is what is the meaning. Presence of this force, presence of this external excitation, okay, during my vibrations. During vibrations, depending upon that, I classify the vibrations into two categories, two types. What are those? One is called as free vibrations. One type of vibrations are known as free vibrations. And what is the other one? The second one is called as forced vibrations. free vibrations and forced vibrations. So in free vibrations, this external excitation is not present during vibration. If vibrations take place in the absence of external excitation, then that vibrations are called as free vibration. Probably I may apply some force at the beginning of vibrations. To induce vibrations, I may apply force. But later on, when the vibrations are taking place, that time this force is not there. So therefore, these vibrations, free vibrations, what do we mean? External excitation is zero. It is not there. It's free from external excitation. Those vibrations are called as free vibrations. So in our discussion in this module number 4, it is going to be only free vibrations. We are not going to have any external excitation. Okay, any vibration in the presence of external excitation, those are called as forced vibrations. Or practically all our vibration problems are forced vibrations. Okay, you may wonder. Okay, so if our practical problems are forced vibrations, then why we study so much about the free vibrations? As I said, this study of vibrations in this subject, part of the subject, is very introductory. So you can't jump straight away and study of forced vibrations. For that, you need to prepare. You need to go through certain basic things. For that purpose, free vibration study is essential. Okay, and therefore, so this is the first basis of classification. Okay, I shall change the basis of classification. I shall change the basis of classification, and then accordingly, what are the types of vibrations? What is the second basis? Okay, similar to that, presence of external excitation. Now what I have is presence of damping. Presence of damping in the system. Damping in the system of vibrations. A system which is undergoing vibrations, and that system has damping or it is not having damping. So again, we have two types of vibrations. 1 and 2. What is that? The first one is undamped vibrations. Undamped. The system is not having any damping. Vibrations will go on forever because there is no resistance. So undamped vibrations. The second category is what is called as damped vibrations. So if I club this and make one more basis of classification, then I can have undamped free vibrations. Undamped free vibration. That means there is no damping and there is no external excitation. Those vibrations are called as undamped free vibrations. I can have undamped forced vibration. Damping is not there, but external excitation is present. Undamped forced vibrations. Okay, then I can have damped free vibrations. I can have damped forced vibrations also. So that also is possible. And you can have one more basis. What is that? What is that? Presence of both. Presence of external excitation and also and damping. So how many types shall we have? You will have 4 types of vibrations. What is that? Undamped free vibrations. Then you will have what is called as damped free vibrations. You will have undamped force vibrations. You will have what is called as damped force vibrations. Damped force vibrations. Okay. So in the present module number 4, what we are going to study are these two. We are going to study these 2 kinds of vibrations in the present module. What is that? Undamped free vibrations And later on, towards the end of the module, we will be discussing damped free vibrations. These are the ones what we are going to discuss under this. Okay, like that I can go on adding. Basis number 4. Basis number 4. What is that? So the nature of movement, nature of displacement, nature of displacement of the mass. How the motion is going to be displacement, or in general sometimes it is also called as motion, nature of motion. Okay, so according to this, I have 3 kinds of vibrations. One is what is called as longitudinal vibrations. This is mentioned in your syllabus. In your syllabus content, it has been mentioned, longitudinal vibrations. Then you have what is called as the lateral vibrations. Number 2, lateral vibrations. And you have number 3, what is called as torsional vibrations. Torsional, longitudinal, lateral, torsional. Okay, I can give you an example for all this. Imagine you have a wire or a shaft of very small diameter or rod. Okay, so a long one, and you have what is called as I fix a mass here, which is in the form of a circular disc. Okay, this length is here, and this is of mass m, and maybe the radius of this is circular in nature, and maybe this is what is r. Okay, depending upon how the motion is going to be, the vibration is going to be, then it may be longitudinal, it may be lateral, it may be torsional. Okay, so if this mass moves along the axis, if this is the axis of the rod, and in this, the mass comes down, the mass goes up like this. So these kind of vibrations are known as longitudinal vibrations. If the movement of the mass is along the axis, then those vibrations are called as longitudinal vibrations. Now the whole unit, this mass, okay, now I imagine that this whole thing is cantilever, and then this mass moves like this, as if it is a pendulum, like pendulum. Okay, so it is not like pendulum. In pendulum, the whole unit is always straight. So now, not necessary. It is like a beam now. Okay, it is a beam, so which behaves like this. You have this like this, or it may be something like this. So these vibrations which take place perpendicular to the axis. Okay, please remember, in the first case, longitudinal motion, longitudinal vibrations, how the motions were? Motions were along the axis. Very, very important word. Along the axis. Now the second one, lateral or perpendicular to the axis. If the motion is perpendicular to the axis, those vibrations are called as lateral vibrations. Now the third one is about the axis. Along, perpendicular or lateral. The third one about the axis. About. This rotor is there. Okay, I shall draw one more. This is the rotor. Okay, this is the view of the rotor. Okay, if I draw one line, radius line, I just draw taking chalk. Okay, now this disc will be moving like this, or in other words, this chalk looking from the top, it may move like this, or it may come. So this disc will be moving like this. Okay, so this motion is about the axis. Please remember, it is about the axis. Okay. So accordingly, longitudinal vibrations, the motion is along the axis. Lateral vibrations, the motion is perpendicular to the axis. And torsional vibrations, the motion is about the axis. Then these are the kinds of vibrations based on this. Okay, like that I can go on adding some more bases anyway. For the sake of completing, I shall go on B5. So what are called as? So what is the behavior of components? Behavior of components of vibration system. What are the components of the vibration system? Stiffness, damping, mass, okay, external excitation. External excitation, you know, that also maybe it can be included. So all these components, whether they are linear or whether they are non-linear. Okay, if you plot a graph, okay, if I say y, probably you will appreciate if the moment I introduce what is meaning of non-linear, you will understand what is the meaning of linear. So if you have say y is equal to a c into x, y is equal to c x plus something, some constant also, 5, or let me write it, y is equal to 3x plus 5. So y and x, both of them are variables, and of course only one of them is independent variable. If x is independent variable, then y is called as dependent variable. Okay? Only one of this y or x can have value independently. That variable is independent variable. The moment you decide the value of x, any value, say x is equal to 0, what is the value of y? Y is equal to fix. Y is 5. If x is 1, then 3 plus 5, 8. If x is 2, 3 into 2, 6, 6 plus 5, 11, like that. So y and x, what is the relationship between y and x? It is linear. If you plot x and y, okay, then this is going to give you a straight line. Two variables are said to be linear if their relationship is a straight line. If you are able to draw them, plot them, if you get a straight line, then we say that they are linear. And similarly, if the moment I change it, it becomes 3x square plus 5. So now I know that it is no more straight line, it is a curve. Then y and 6, what is the relationship? It is a non-linear relationship. It is not linear. Similarly, depending upon the stiffness of a spring, the damping, external excitation, all those, okay? If they are linear, then it is called as linear vibrations. The vibrations are called as linear. If they are not linear, then we call them those vibrations as non-linear vibrations. Fortunately, in our course, in this, okay, part of the down, okay, we are going to have only linear. And I shall add one more basis like this. As I said, 5th semester students classification, if I can go on adding the basis, here also I can go on adding. I shall add one more and then wind it up, the classification of vibrations. What is that? B6, the 6th basis. What is that? Okay, estimation of excitation. Estimation of excitation. Is it possible for me to calculate how much is the force which is responsible? Please remember, these forces are not static forces. These forces are dynamic forces. Every instant that force will change, maybe in magnitude, maybe in direction, or maybe both. So therefore, these dynamic forces, is it possible for me to estimate? So after say 2.5 hours, this will be the excitation. If I am able to calculate that, then I say that yes, I am able to estimate the force. If I am unable to calculate such force, then I say that it is unable. Okay? Then accordingly, I have two vibrations, two types. One is called as deterministic. That means it is possible to determine. Determine what? Determine the external excitation. It is possible to find out what is the external excitation at any time. Then such vibrations are called as deterministic vibrations. Then the second one is the other vibrations which are called as random vibrations, non-deterministic, or which are also called as random vibrations. If it is not possible for us to find out what is the amount of external excitation, then we call such vibrations as random vibrations. Though we have so many types, etc., etc., as I said, in this module we are going to study what is called as undamped free vibrations and damped free vibration. And in the next module, module number 5, what do we study? We take up what is called as forced vibration. So what type of forced vibration? It may be undamped forced vibration or damped forced vibration. So we will be studying this topic in module number 5. And when you make the analysis, if you substitute damping equal to 0, then that study becomes this also. Okay? So though we are studying this, and I can also say that we are covering this also. Okay? In module 4 we are studying this. In module 5 we are studying this. Little bit of this we are going to study in module number 5. Okay? So this is about what are the types of vibrations. Now, okay, we are almost ready to introduce you what is vibrations. Okay, we are ready to take off to what is called as analysis of vibrations. Okay, before I really go to the analysis of vibration, I shall introduce you one more term. One more term. So, couple of terms. One more is what is called as a resonance. Resonance is a term. Okay, resonance. A very common term. What is resonance? Resonance. Resonance is a situation basically. Okay. So, what is that situation? So, I have a system, as I said, say I have forced vibrations. So, in forced vibrations, I have something what is called as external excitation. As I said, that external excitation is also harmonic. That means it is also a simple harmonic. Okay, it also has frequency. So that means frequency of external excitation. Frequency of external excitation is same as the natural frequency of the system. Then we say that we have a resonance situation. I'm sorry, I should have introduced you resonance after introducing what is called as the natural frequency. Okay, no problem. What is natural frequency? Natural frequency, as he says, it is frequency. Frequency of free vibrations. Frequency of free vibrations is known as natural frequency. Okay, I have a system, for example. So I have a system. What is this system? This is called as a spring mass system. I don't have damping. Okay, so I don't have external excitation also. And I find out this and I introduce vibrations. What do? I just pull this mass, say up to here. I have applied force, no doubt. But I remove that force. I pull this mass here and then remove. Then what happens? This mass will continue to vibrate like this continuously. Continuously. How long? Theoretically infinite time. Because there is no resistance which is stopping that. Okay? So when I do this, I put this and leave it here and I have pumped some amount of energy and there is no loss of energy and therefore this will theoretically go on this thing moving. But that will not happen because why? There is naturally some resistance is there. There is a joint here and this is going to move in air. Air will offer resistance and therefore after some time that energy is lost and probably it may come after some time. If you come and see, then it might have stopped. Okay, but theoretically, as I said, it is this thing. So okay, what I wanted to introduce, okay. So now I allow this to move, I apply force, but remove that force, it is taking, vibrations are taking place in the absence of any external force. Therefore, I find out what is the frequency. What is the frequency? So how many cycles do I have in 1 second? Okay, it is moving like this continuously. It is difficult for me to find out how many cycles are there in 1 second. It is very difficult. Okay, probably I find out how many cycles take place in a fixed time, or the other way. I count the time, I note down the time required for 10 cycles. So 10 cycles, okay, 10 cycles take place in so much time. Then T divided by that N. N for N cycles, what is the time required? T divided by N. This is nothing but the time period. The time required for 1 cycle. Then I find out what is 1 by T. What is 1 by T? 1 by T is equal to F. That is nothing but frequency. Okay, since these vibrations are free vibration, whatever frequency you find out now, this is given a special name F suffix N. What is that? Natural frequency. It is a natural frequency. So now I apply some force to this. What is this force? F naught sine of omega t. So because of the sine omega t, F naught is just magnitude. Something like 10, 20, 50 like that. It is only amplitude. So depending upon sine omega t, it may be in this direction or it may be in this direction. Therefore, this mass is made to move up and down because of this force. So now this omega is called as the frequency of this excitation. The frequency of external excitation. If it matches with the natural frequency, then we have what is called as the resonance. Resonance is a very, very dangerous situation. If you allow any system to run at resonance for some time, the whole system is likely to fail. So you might have heard maybe in your school days, say the army is marching on a bridge. Army is marching on a bridge. The army is told to break that marching and then walk smoothly, and then after the bridge they let them again march at a regular distance. Why? It is because if the frequency of that marching coincides with the natural frequency of the bridge, then huge amplitude vibrations will take place and the bridge will collapse. So that is the reason. So we don't want to have resonance. The very first module is we are going to find out the natural frequency of the system. I want to find out the natural frequency of various systems. Okay, so that if I know the natural frequency of the system, then I can see that whenever the external excitation I have to apply, this frequency is much away from the natural frequency, so that resonance doesn't occur. That is the idea. Keeping that in mind, all our remaining time of study on this module is going to be on finding out the natural frequency of various systems. Of course, before that, again, the method of study that I shall learn, how exactly we need to carry out, that we shall discuss and then carry on. Okay, good day.